Welcome to MyProjectBazaar.com. Our product title is a 28 nanometer CMOS 1 volt 3.5 GS bar S6 bit digital to analog converter with signal independent delta 1 noise DfT scheme. Next we see about abstract of our product. A digital to analog converter is a function that converts digital data into an analog signal. An analog to digital converter performs the reverse function. Unlike analog signal, digital data can be transmitted, manipulated and stored without degradation, albeit with more complex equipment. But a digital to analog converter is needed to convert the digital signal to analog to driven a 3.5 GS bar S6 bit current steering digital to analog converter with auxiliary circuitry to assist testing in a 1 volt digital 28 nanometer CMOS process. The DAC used only thin oxide transistor and occupies 0.035 nanometer and making it suitable to embedding in VLSI system. Designed for test stands for IC design technique that adds certain testability features to a hardware product design. Next we see about the flow diagram of our product. This is our flow diagram, and the first one is the clock. Clock is enable the flip-flops and other registers, and this is the data. The data is given in the format of digital format, and the DAC works by using the time interleaving of individual sub DAC to provide a composite output that is much faster than the sub DAC. The output from an ideal DAC that has a zero order hold output, and the black sinusoid is the original ideal analog signal that has been digitalized and fed to the DAC input. The blue stair step pattern is the ideal output from the DAC. One of the first 28 nanometer DAC implementation and the first high speed 1 volt only design. The use of shift register as a core memory block in the test assisting structures present in the work. Higher measured SFDR performance up to 800 MHz among the published 6-bit CMOS DAC. Scalable test assistance block. Detailed description of an on-chip test assistance apparatus. 8.1 high-speed CML Mux implementation for data reconstruction, and high-speed CML gate design approach based on only 2 gate types. Generally, the system proposes the DAC design and strategy with the advanced CMOS process. The proposed system resents the novel test and existing blocks. Embedded data convert recur implementation of CMOS technology process chosen for the digital platform. In the case of the most recent digitally advantageous IC process, the data converted by a recur operation with a single 1 volt power supply. Conventionally, DAC design approaches are not directly applicable with such low voltage headroom. This section reviews the traditional DAC design approaches and proposes strategies for designing in advance and to reduce the drawbacks of the slow switching slopes of the data drivers and its attempts to match the transition edges of the MSP DAC bits and to relax their negative impact on the performance through uncertainty. The common 50% level segmentation is applied as a trade-off between linearity and area. Next we see about the running process of our product. In this proposed work is done by Tanner EDA tool. Tanner EDA tool is a designing software tool is used to design the architecture of VLSI designs. In this proposed work consists the following modules such as test assistant, 6 CML input flip-flop, 3 to 7 binary to unary decoder, 10 CML data drivers and digital to analog switches. Generally, test assistance block provide the DfT schemes and it also provide through data reconstruction to perform the digital to analog conversion. Thus, the test assistant block consists of GML to CMOS conversion, data ring register, CMOS to CML conversion, and data reconstruction. Next one, the subclock block in the test distance. In that block, the clock signal is provided to the D flip-flop or used to provide the clock signal to the enable and align block and to the data reconstruction block. The clock pulse is initially given to this block, then the clock pulses are considered as the CML signal. Then the CML signal are given to the CML to CMOS conversion block. Next one, the enable and align CML to CMOS conversion. In this block, 8 register and 8 AND gates are used to provide subclock input to the next block. That serial data are given as input in this block. Then the output of this block provides subclock signal to activate the next block. Next, data ring register. The purpose of data ring register are connected as the input clock signal is given to the ring register to perform continuous data output. Next one, CMOS to CML conversion. In this block, the CMOS signal are converted as the CML signal. For further operation, the CMOS to CML conversion has 8 sub-blocks as input. Then it performs the conversion operation. Then it provides 8 CML signal to the output of the data reconstruction block. Data reconstruction block is nothing but reconstructed by using the MUX block. It has 2 input and 1 selection line as the input. In this data reconstruction, 6 MUX blocks are used, and the output of the data reconstruction block is given the input to the CML flip-flop, and that flip-flop are used to divided to MSP and LSP bits. And finally, binary to unary decoder function is current cell and binary current cell are used. This block is used to convert the digital signal to analog. The binary to unary decoder converts the digital signal as analog signal. As the output of binary to unary decoder, the 10 combination of the digital to analog signal are provided. Finally, we get the analog signal. This is our output waveform. This is the input digital signal. This is the corresponding analog signal. So the given digital signal is converting according to the process. The analog signal is getting the output.